So, um, hello everyone. So, augmented reality, or more or less mixed reality, is something that everybody of you probably heard, or at least everybody who has played video games like me in the past is very excited about. What this talk is about, since we're about React as front end, how we are actually using 3D elements and how we can actually use them to facilitate, first of all, user experience, and of course, how we actually get to do that. So, augmented reality is this really new thing. It's a new medium, like text, video, images. And this talk is about how we are actually getting there with React Native. So, the first kind of thing that 2D is hard. 2D was very, very hard for a long time on mobile, different frameworks and so on. And React Native made it simple. Not necessarily easy. We every day kind of fight with it, but still, we're able to work with this very productively. We have a clue about hierarchy, everything. Well, when we think about 3D as an experience, this is a lot harder. If you guys have started with the Z index, now imagine you have 3 of those. So it's a little bit difficult to kind of get your head around that. So augmented reality is going to be this really new, complex medium. And it doesn't really matter what kind of abstraction you kind of think about, be it something like a game engine like Unity, or a simple front-end framework, simple, like React. So my talk is going to be about React Native bridges and how we can actually instrument them to get this new medium into our hands to actually do something beside gaming for our front-end experience. And mind the S. I mean, we have, of course, bridges to the device, but there are many others. And of course, for us, it's important now to think how we actually get to the GPU, how we were able to get graphics on the device. So about me, as introduced, I'm primarily in the area of business. I do like business conferences and stuff. I'm very involved in the retail space, and this is also what we do as a company. I'm the product owner at ShopLink. We're not launched yet, but basically what we do and try to do is to get this beast, augmented reality, to behave in a way that we're able to steer users or consumers inside of a retail store to new experiences. And since you don't find anything about that online, because our website is basically a landing page for TechCrunch right now, which is on Monday, and we're there as well. And let's try if that works. You see, we basically recognize packaging and the different kind of complementary goods and try to wrap 3D models or interactivity around that. And that sounds like a really novel idea, but the problem is still either that's very heavy if you use something like Unity, or it's very complicated to implement if you use something like React or native development. So let's do a little crash course. Crash course augmented reality. I mean, this is the part that has not so much code in it, but more gives us an understanding how we get away from those augmented reality YouTube videos where people put virtual cats on their couch or something like that, to kind of get a better idea how we can deal with this. So what is augmented reality? Well, when you think about augmented reality, we have this space. We call it the immersive computing spectrum. Basically, on the left side, it's you taking a walk in the woods, like real. And on the right side is what we call virtual reality, when we think about the headsets and everything is augmented. Well, in the middle, it's clear we have the combination of the real world, and in there we detect something, and then we place our user interface, so to say, into that space. Easy. Probably some of you have already seen this chart, but the problem is that this part here in the middle, that's still pretty steep. And there are actually three more abstractions which we have to think about for augmented reality. And those three basically start also and interestingly kind of align with how augmented reality or actually object recognition came to place. It all started out, this is a video or clip from 2007. On the bottom you see natural feature detection, so trying to find interesting points in the environment to navigate. Did not really work. So we know there's a marker, or in this case a poster, has a specific size, and if you know math, Pythagoras, you kind of calculate where the camera is. Then the next step came parse maps. So AI or machine learning systems got really well in detecting patterns and creating clouds and trying to differentiate what is actually moving and what is actually static to give you a really, really good sense where in the world the real world your digital camera or viewport is. But that's not enough. I mean, if we project something here into this room, could be like a car, the car would be like sitting into the wall because we don't know there's a wall, there's something else. So this latest step, and the step that's most exciting, is actually environmental structuring. And some of you have maybe heard of SLAM. Actually, there's also another abstraction via VOI. And what you see here is basically the Oculus, the HoloLens, using its information to define what the environment is. So you are able to actually kind of like slap from a mobile device your UI into the room. So that's very easily understood, and that's what we call mixed reality. And that's something for user interfaces very interesting. But do we want that? I mean, we are front-end devs, yeah? And when we think about front-end, do you want that in mobile? I mean, it's a tiny screen. So when everyone of you thinks probably about virtual reality and augmented reality, you kind of think about this. You have this headset, this HoloLens, it's super spacey. You're able to kind of like take a walk and pretend you're on the Bahamas and not in freezing Berlin. And that's legit. But there are actually three very good reasons to try AR, especially from a front-end perspective and a user experience perspective. The first one is accessibility, intimacy, and it's relatable. What is that? It's not just a furious grandma, it's actually a Wii remote. It's something that's by now almost 10 years old, but it was a tool to interact with the real world in a very intuitive way. And when we think about our front end, our goal is almost always to make it as intuitive and easy to use as possible. So when you have those digital tools, and there it was not even a mobile phone, it was a small TV far away from you with a controller that sometimes worked, sometimes didn't, but even elderly, but also people who didn't have patience are easily able to learn this really quickly. Intimacy. So who knows what that is? Yeah. Well, last year I was in Cologne, sitting in a brewery and of course like playing Pokemon Go and trying this out and everything. And then all of a sudden on my table was this guy. So I don't know about you, but what kind of elements do you have in your mind right now with, for example, React Native or mobile development in general to kind of create this thing of intimacy? There's something in your personal space and not just behind a glass screen. And here you kind of like, okay, I can grab it, I can catch it, I can whatever, but also you can make maybe other user interfaces like that. So, and then relatable. Relatable is about understanding and having a feel where something is beyond the edges of your screen. So when you look in this direction or that direction, you probably have in your mind that, for example, the chairs extend to the walls, etc. And now come the less risky part. Let's hope the Expo guys did their thing. So what Expo did about a few months ago in September, they released a blog post. Very easy. And the blog post was about Expo supports augmented reality now with ARKit. Super. And the thing they did is quite simple. They took WebGL bindings and linked them to merge them to the information that you actually get from the sensors and the detection of ARKit. So what this thing is supposed to do, under the assumption that we are now able to live code on this. So on the right side, if you're kind of confused, this is basically the mirroring of the iPad. And the high performance of Expo right now under the network conditions. If we have an Expo crack here, just give us a shot, but let's try the tunnel. So basically just to continue this thought. The idea is as simple as we can get it in sense of we have the problem of generating 3D content in the real world on our devices. Well, that was solved on the desktop a long time ago. We call it WebGL, the canvas element, 3JS, and also other elements. And then we have those innovations on the mobile field, which are things like highly calibrated cameras. They are able to stream and in real time estimate the global position of yourself, your intent of movement, and also detect, for example, the surroundings. And what we need to do for React Native or React developers in general is to find a way to kind of bridge that together. And whoops, so I give it one more shot, and otherwise I skip forward. Yeah, so. So what it's doing now, if you don't know Expo, it's just throwing over the JavaScript bundle. And actually, ARKit is already encapsulated in the current Expo SDK, which of course makes it very easy to kind of like play around with it. And the goal of this demonstration is actually not so much to show what the capabilities of Xcode are, but what actually the performance is between the binding of a WebGL layer and basically bridge that is streaming all the coordinates to your device. So, good. Applause for Expo, please. We maybe revisit this later, but for now, let's skip on. Okay, so basically what I was going to show you, and I can show you in a little bit in the code as well, it's of course nicer to see when it's live updating, is a very simple illustration of 3JS. Some of you are really like, okay, I know 3JS, but there are actually some more examples in a general understanding how we can build AR with React Native through this very basic code line. So when we think about WebGL, WebGL is a canvas tool. It's actually used to get the OpenGL, ELS bindings, some other bitmap and vectoring methods from the GPU accessible into the HTML DOM. So we have this canvas element. This canvas element is actually creating a context which allows us to throw very linear graphic calls into our GPU. And there's a project out there, and it's called React Native WebGL. There is, for this Expo version, a similar, almost copy of it bundled into the SDK. And when you look here at this part, you kind of see, okay, we're killing the Windows event listeners, because we don't have a DOM, and 3JS probably doesn't know then what to do. We require 3, add it to the global, and then it gets really interesting and simple. We are able, with the GL, to create our own WebGL context. And this WebGL context we can basically just throw in as a polyfill for the canvas without the DOM, without a web view, and without the overhead of communicating between React Native and, for example, a website that runs on your server. And after that, we basically just set the color, set the width, take our camera image, and overlay the web view and stream basically information like the camera position from ARKit, ARCore, Vuforia, or other libraries into the system. That's it. I mean, those are basically 600 lines at most that enable you to build very high-performant experiences without requiring you to kind of do the hacks with, for example, WebSockets into a website or something like that. So the question is still like, could we use the web view? Yeah. And there are actually like Prefab and some other companies out there that have a mobile app to demo, for example, 3D models, and they use a web view. And it's an intermediate good solution. But we have not worked for 10 years for CSS3 and all the performance increases and hardware acceleration to kind of fall below 60 frames per second. So coordinating with the web view is really just, well, a start, but when you really try to figure out a way like we do to get this performantly done, it's not an option. So who has done it now? So there's this guy, his tag is really Gree, and he wrote already some time ago a polyfill for the WebGL context within the canvas element that runs inside of the Android device platform and the iOS device platform. It's a very intelligent way, and actually I think he didn't even anticipate to do this kind of stuff because his background is actually in blockchain. I don't know if he tries to mine on thousands of Androids or so, but theoretically having access to the very simple computational calls on the GPU, it allows you to grab a lot of performance out of a corner we kind of forget today because we think about the bridge to the button of, for example, the iOS device. And yeah, so WebGL without the DOM basically gets you to the point where we need the canvas. We have bridged by now React Native all the buttons, all the icons, all the very heterogeneous kind of API calls that are made to kind of create the context of a good front-end library, but the canvas or the GPU is kind of left behind. And that means I took this gap into in the React Native ecosystem and did what any great hacker would do and fight an issue. Yeah, so I posted it today. It's a little bit longer, but basically it lists the potential of bridging the canvas from the HTML world back to the native devices from iOS and Android to enable us to use all the great frameworks that are out there. And they're great libraries, not just 3JS, that are built on top of WebGL And what most people don't get, because we are like crazy about the last NPM version, and if something didn't get updated for 3 months, it's like outdated. OpenGL, it's 40 years old almost. And right now, the WebGL standard 2.0 took like 12 years in the making. People are starting to adapt it right now. So the APIs from the canvas don't really change that much. And when we have them bridged once, you can basically go on NPM on any whatever web tool, throw it into your stack, be it 3D or 2D, and use it into your system without some weird hacks. And actually, Facebook did implement some of that for the header bar of their Facebook app for 2D draw animations for like the collapsing. So this is ticket number 17051. I invite you to try to use this thumbs up, or if you are really eager like me, maybe contribute there as well. And if you're really crazy, I'm also doing that. It's kind of like prototyping with colleagues how something like that could look like. So, okay, rendering is one thing. It's very cool when we are able to render stuff in 3D and so on, but interaction really works differently. So we need libraries. We need libraries to be able to reflect interactions, for example, like physics, whatever. And there's like the question libraries. Who of you uses Babylon.js? Yeah, okay, a few. So if it loads, the net here is taking its toll. Yeah. So this is 60 frames per second, WebGL optimized, and it's actually a game engine as well, with physics and everything. And if you kind of think about the Material UI design set, which tries to incorporate shadows and also like physical intuition tweening to kind of give feedback to pushes on buttons, etc. There's already now, this thing is created in 2012, available with high performance that also work on mobile. And of course, when we have the canvas, also on any other device. So, where's my mouse? So, Babylon.js is WebGL implementation that is also a game engine and has incredible import and export features for example, Unity developers, 3D designers, etc. And when I saw it, I was like, wow, crazy. I must have missed that like for a year or so. And then I realized the marketing sucks. Because I was seriously thinking all the time, like, okay, Babylon.js has to be Babylon, the transpiler, which is obviously not true. Today, Babylon is more known as Babel, but those guys started pretty much at the same time and probably didn't know about each other. So I went on Twitter, since the characters are now a little bit more than the 100 whatever characters it was, and tweeted to this Microsoft guy, the owner of this project, and expected like, yeah, okay, we'll see. Maybe next month he comes back, and he actually came back within 30 seconds or so. So what do you want to do? So I wrote him like, okay, we have this idea of actually binding the OpenGL directly to the device and having the ultimate AR platform out there readily in your hands based on JavaScript. And he tagged his colleague also, David, also at Microsoft. Should be feasible. So I gave it a shot, and it's kind of in the making still because we're a little bit occupied. But what we're able to do, and that's also kind of the last point, is that Babylon.js, whoops, and this is TypeScript, by the way, allows to implement or pass on custom context. So when we have, for example, this canvas element, we just throw it in there, it will work because the WebGL specification is everywhere the same. Okay, so this was like my road down this rabbit hole. Yeah, I'm really sad that the demo didn't work, but basically from the code snippets, it's exactly the same thing I just showed you before. What's really interesting to do is basically real-time updating this thing, throwing WebSockets in there so you can interact with users together and stuff like that. Okay, so I lost a bit track of the time, but if you have questions, let me know. Otherwise, the ticket, throw your thumbs up in there. Thanks.